Okay, I'm going to try and work this problem in a really organized fashion. So the question is asking me to find the extreme values of this function. So what I know that I need to find is I need to find, are there any endpoints? And I need to find what are the critical points. And the critical points are where f prime of x is equal to 0, or where f prime of x does not exist. Those are the only places that I can possibly have extrema, at the critical points or at the end points. So one thing I know going into this problem is that this is my f of x. I know I'm going to have to find the derivative. I'm going to have to find f prime of x. So let's just kind of do that right now and make sure that we got that correct. And in order to do that, I mean, I could do uv and use the quotient property, but you know, I kind of like, I don't like the quotient property. It causes me too much aggravation. So I'm going to change this function. I'm going to rewrite it. I'm going to rewrite it as the square root of 9 minus x squared. Well, no, I'm going to write it even differently. I'm going to write it, first I'm going to write it 1 over 9 minus x squared to the 1/2 power. And then to make it really easy, I'm going to rewrite it as 9 minus x squared to the negative 1/2 power. And then I don't have to mess with the quotient rule at all here. So when I want to find f prime of x of this function, I'm just going to use the normal power rule and inside outside. So I have negative 1/2 9 minus x squared to the negative 3/2. That's the power rule on the outside. And then I have to do the derivative of the inside, which would be times negative 2x. So let's just kind of go over to Desmos here and double check. So this red right here is the graph of my function. You can see it right here. I'm clicking on and off. And then the graph of the derivative of that function looks like that. And then the derivative that I calculated, I want to make sure it's right. So I wrote it in here already, and I'm going to click on that, and we can see that it is exactly the same graph as the blue g of x right here. So I'm very comfortable that my derivative is correct. So now that I have the function and I have the derivative, I'm going to find the domain of the function, and then I'm going to find the domain of the derivative. And I'm going to find the domain of the function because finding the domain of the function gives me my endpoints. It will also give me some places where the function does not exist. And if the function doesn't exist, then there can't be any derivative there either. So if there's no derivative, well, if the function doesn't exist, it obviously can't be an extrema because there's nothing there. But the main purpose of finding the domain of the function is to find the endpoints. So here's my function again, and I'm going to go through don't ride lions, dear, which reminds me that I have to check the denominator, any radical signs with an even index, logarithms, and whether the domain is defined. So I know that the domain isn't defined because it doesn't say anything about it there, so that one's crossed off. But let's start at the top, actually. That's better. So the first question is, does my function have a denominator that includes a variable? And the answer is yes. So I know that my denominator cannot be 0, so I have to find out what values of x will make my denominator 0, and those are going to be excluded from the function. Those are going to not be in the domain. So let's do that on a separate page. What I'm doing here is I wrote down my denominator. You can see that this is the denominator of my function. And I know that that cannot be equal to 0. So I'm going to set up this equation or inequation, whatever the right word is. And I'm going to solve this and find out what values of x cannot exist. So first, I'll square both sides. So I have 9 minus x squared is equal to 0. I'll subtract 9 from both sides. So I have left with x. Slow down. X squared equals negative 9. I multiply both sides by negative 1. I get x squared equals 9. And then I take the square root of both sides of that, and I get x. This should be cannot equal. X cannot equal plus or minus 3. So my domain of this function right now is the only numbers that are excluded are plus and minus 3. So negative infinity to negative 3 union negative 3 to positive 3 union 3 to infinity. That would be the domain based on the first step, which is the denominator. But going back to my function and how I solve for domain, I took care of the denominator part of it. But now I have to do the radical part of it, because my function does have a radical sign with an even index. This is a square root. We know that this 2 here is implied. So I have a radical sign with an even index. And in order to solve that, I have to set up an inequality that takes the radicand, that is the part underneath the radical sign, and I have to set it greater than or equal to 0, because if I'm looking at my, let's look at my function right here. I have a radical sign, and we know that there's no, the square root of a negative number is not a real number, and my domain has to be in the real number universe. So that's why I'm setting the radicand greater than or equal to 0, so that I can find out, well, what else is going to be, what other values of x are going to be excluded from this domain. Now, this next part that I'm going to do right here is what you want to do, and it is going to be incorrect. But I'm going to show you what it is so that you can see what is the incorrect way to do it, and then I'm going to show you the correct way to do it. So first, let's make a copy of this. And this is the incorrect way. So I'm going to write it right here. Incorrect. But this is what everybody kind of wants to do. So what people want to do is they want to look at this and say, okay, I have this inequality. So I'm going to subtract 9 from both sides, and I get negative x squared greater than or equal to negative 9. And then I'm going to multiply both sides by negative 1. And you know, when you have an inequality and you multiply by negative 1, you have to flip the inequality sign. So I'd have x squared less than or equal to 9, and then take the square root, and I would get x less than or equal to plus or minus 3. So if I drew that on a number line, x less than or equal to plus or minus 3, here's 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That would look like this, less than or equal to positive 3, so that would be here going that way. And less than or equal to negative 3 would be here going that way. So really that would be telling me that this part means that only from negative 3 that way is part of the domain. But that is incorrect. And let me just show you something on a graph that will show you why this is incorrect. Because what I'm going to do is I'm just going to graph right here this part. I'm going to graph the radicand, and you'll see what it looks like. What I did here was I actually graphed the whole denominator here, and you can see that the square root of 9 minus x squared, the domain of that isn't negative 3 going that way. The domain of that function is going from -3 to +3. So I really am looking for -3 to +3, but I can't remember, well, I can remember, but you might not be able to remember how algebraically we get there. So now let's do it the right way, and that is by treating this as what it is, which is a polynomial inequality. And when we want to solve polynomial inequalities, we find the zeros, we set intervals, and then we test numbers. So what I first need to do to solve this inequality is I need to find what are the zeros of 9 minus x squared. Well, we actually did that earlier when we were messing around with the function. We found that the zeros were +3 and -3. So those are the zeros of this 9 minus x squared. So I'm going to set up a number line now. And I'm going to mark my zeros on it. I have -3 and I have +3. And what I need to do is I need to test, well, let's write the intervals that I'm dealing with here. I'm dealing with the interval -infinity to -3. I'm dealing with the interval -3 to +3. And I'm dealing with the interval +3 to infinity. So what I need to do is I need to test numbers in each of these 3 intervals and find out in which interval is this true. 9 minus x squared is greater than 0. So let's do. The number I'm going to test in this interval here, I can pick any number I want, is -4. The number I'm going to test in this to make that a 4, in this interval here is 0. And the number I'm going to test in this interval here, I'll do +4. So over here, I'm going to test the 3 numbers that I selected off of my number line, -4, 0, and +4. I'm going to test each one. So f of -4 would equal 9 minus -4 squared. And I can see that this is going to be 9 minus 16. So this is going to be a negative number. If I test 0, it's going to be 9 minus 0 squared. That's going to be a positive number. And this is going to be 9 minus +4 squared, which is going to be, again, 9 minus 16, which is going to be a negative number. So the only number of these 3 that I tested that makes this true, 9 minus x squared, greater than or equal to 0, is this one right here, because it's a positive number. Positive numbers are greater than or equal to 0. Negative numbers, they're no good. Those are not making this true. So my domain, according to this, the second step of finding a radical, would be just from -3 to 3. And it would actually include -3 and 3, except that the denominator test for my domain says no. -3 and +3 can't be part of the domain. So really what I'm doing here by all this work is I have eliminated that as part of the domain, and I've eliminated that as part of the domain. So right now, the domain of the function is straight up -3 and -3 to +3. -3 is not included because that made the denominator 0. +3 is not included. So what this tells me and I'm kind of keeping this page a little bit separate, is I have no endpoints. So I don't need to worry about endpoints with this, with finding the extrema here. So I have no endpoints on this function. And only way I was able to find that was to find the domain of the function. Well, since I'm off into domain right now, what I'm going to do is I'm going to find out, well, what's the domain of the derivative? Because that is all that's going to tell me if where the derivative does not exist. If I find the domain of the derivative, I'll find out where does the derivative not exist. I found the derivative fairly early on in this process. And let me just tell you, I'm doing this on different pages of the smartboard, and I think it'd be a good practice to kind of do this in either separate sections of a paper or even on different papers. Because if you run it together like I normally do, it tends to get rather confusing. So this is the derivative, and to find the domain of the derivative, I'm going to rewrite this as negative, actually not negative, because this negative here and that negative there cancel each other out. So this is really going to be 2 divided by 2 9 minus x squared to the positive 3/2 because I put it in the denominator. And now I see that this 2 and that 2 can cancel each other out. So I have 1 over 9 minus x squared to the 3/2 power. And finding the domain of this derivative is actually going to be pretty easy because we've already done a lot of the work. So again, I have a variable in my denominator, so my denominator has to be set equal to 0. Again, can't be equal to 0, so 9 minus x squared to the 3/2 cannot be equal to 0. Well, I'm going to multiply, I'm going to take both sides to the 2/3 power, so the powers cancel out, and I get 9 minus x squared cannot be equal to 0, and I already know the answer to that one. The answer to that one is x cannot be equal to plus or minus 3. Similarly, if I rewrite this as 1, this is the derivative again, 1 over 9 minus x squared cubed, and take the square root of that. So that's what this means. The top is the power, the bottom is the root. Then I have a radical sign with an even index, and that means that the radicand 9 minus x squared cubed has to be greater than or equal to 0. Well, again, it's just going to be a duplicate pretty much of the same thing. I can if I find the zeros of 9 minus x squared cubed, I find where those equal 0 from the work that I did before. I'm going to really run into the same thing. My zeros are going to be -3 and +3. So again, if I set up a number line, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Here is one interval here at -3. Here's another interval here at +3. I'm really going to end up with the exact same result again, because if I test, say, -4, I know that this is going to be 9 minus 16. It's going to be a negative number in here. And when I cube a negative number, this is going to be negative. If I test 0, this is going to be 9 cubed. It's going to be a positive number. And if I go back over here and test +4, again, I'm going to have 9 minus 16, a negative number cubed is negative. So the domain of my derivative is exactly the same as the domain of my function. The domain of my derivative is -3 to 3. And there's no place between -3 and +3 that it doesn't exist. So the domain of my function is -3 to 3. The domain of my derivative is -3 to 3. So now I'm in a good position to find the rest of the critical points. So again, just to summarize on my main page here, the domain of the function was -3 to 3, but it had no endpoints. The domain of the derivative was also -3 to 3. So the places where it did not exist were places where the function didn't exist. So I'm not really concerned. There's no other place like between -3 and 3 where the derivative does not exist. So now what I'm interested in finding out is where does the derivative equal 0? So I had simplified my derivative to this. Let's actually give it a name here. This is f prime of x. That's so ugly, but we'll leave it. And I want to find out what values of x. You know what? I made a mistake. That isn't the derivative simplified. Because back here, I was correct in getting rid of the negative signs, and I was correct in getting rid of the 2's, but I forgot that there is still that x right there. So the actual derivative is x divided by 9x squared to the 3 halves. That doesn't make any difference in my domain. I still did the denominator thing and I still did the radical thing. The domain stays the same. But now it does make a difference because I need to find out what values of x will make this equal to 0. And when you're trying to find out what values make a rational function, that is a polynomial divided by a polynomial, what makes it 0, you only have to worry about the numerator. And the reason is this. I'm going to go x divided by 9 minus x squared to the 3 halves equals 0. And again, I'm trying to solve for x, so I'm going to multiply both sides here by 9 minus x squared to the 3 halves times 9 minus x squared to the 3 halves. So these cancel out. This remains 0. And all I'm left with is the numerator, x equals 0. And indeed, that is the critical point. That is the last piece of the puzzle here. Well, not the entirely last piece of the puzzle, but where f prime of x equals 0 is at the point 0. That's my x value, and I need to find the y value. Well, the way I find the y value is by plugging 0 into the regular function, and I can see that that's going to be 1 divided by the square root of 9 equals 1/3. So the critical point where I might have a maximum is the point 0, 1/3. No endpoints, no places where the derivative does not exist. There is one place where the derivative is equal to 0, and that's at the point 0, 1/3. And if I kind of go back here to my graphs, I can see this is the graph. Let's get rid of this one here. This is the graph of the function, and I can see that it looks like I have a minimum right here at this point of 0, 1/3. And when I look at the graph of my derivative, I can see that my derivative is equal to 0 at the point 0, 0. So the x value where my derivative is equal to 0 is actually 0. And I have right here an extrema. Now, I can look at this. I know it's not a maximum. I'm guessing it's a minimum. but I need to be able to show algebraically that it's a minimum. So here's my derivative. I'm going to make a number line. Here's my only critical point, is right there at 0. So I need to pick a number. I have my function only goes from -3 to +3. So I have to pick a number between 0 and -3. I'll pick -1, and I'll pick a number between 0 and +3. Those are my only two intervals here. I'll pick +1. And let's find out what that does to the derivative. So when I'm finding f prime of -1, I can see I have a -1 on the top. And on the bottom, well, on the bottom, I'm going to have 9 minus -1 squared. That's going to be 8. 8, I don't really care what the actual value is. If it's cubed, it's going to be a 8 cubed is going to be a positive number. And then I'm going to take the square root. And the square root of a positive number is also going to be a positive number. So I'm going to have this over some kind of a positive number. So it's telling me that the slope between -3 and 0 is a negative slope. The derivative is negative. It's going to be a negative slope. If I do f prime of +1, then my numerator here, let's go back up here. The x is going to be a +1. My denominator is going to be the same 8 to the 3/2, which is going to be a positive number. So this is going to be a positive slope. So I'm going to have a negative slope to a positive slope. It means that that point at 0 is a minimum. So back here to my main page here, I'm going to write this as a minimum. And then looking at the graph, I can see that that is an absolute minimum. There's nothing else more minimum than that. So back to my problem. It's a minimum, and it's absolute. So that's that problem.